Precision and accuracy are really two of the cornerstones of good engineering. It's important in so many different areas, not just in design, but also in production and in implementation. Nowhere really is more important for us for precision in the motorsport environment than the alignment of a race car. Those 4 tyres are the only 4 contact patches that that car has with the rest of the world. And every force that the driver feels, every force that the car feels is reacted through those 4 tyres. It makes it critically important that those tyres are aligned in a way that is best suited not only to the track conditions, not only to the driver, but also suited to the circuit that they're at that time. And so it's a real tool in our toolbox in race engineering to be able to change the alignment of the vehicle. One of the things that we need to make sure that we do every single time is that we are accurate and we are repeatable. We need to know exactly where those tyres are in contact with the road. There are some really complex measuring systems out there available on the market. There's some systems that use laser sensors, there's some systems that use ultrasonic sensors that enable you to set up a vehicle quite quickly. One of the downsides of those systems is they're very prone to user error, and you really need to be able to trust the process. And so for us and a lot of other teams within motorsport, we use a really low-tech solution. We use essentially some rulers and some strings. Let me talk you through that process. This first step arguably is the most important. It's leveling up all of the corners of the weighing system and measuring system. This gives us a flat plane datum from which to work from. And so the guys will spend a fair amount of time just making sure they're really precise in this stage of the setup. The tool that we see in the middle is just a laser level. It's just projecting a kind of a circular beam around all of the patches that the guys are using as a single point of reference. Those pads themselves are then being leveled up individually, as well as being leveled up to that laser, so that we know within 3 axes, each of those pads is level with the floor and with one another. The mechanics have now rolled the car into position where they leveled up the pads earlier on. They've lifted the car on the air jack system and they've put some elephant's feet underneath. These are just safety stands that support the weight of the car when the air jacks are lifted. They're 2-stage, so they allow the mechanics now to lift the car a little higher if they need to. Now that the elephant's feet have been positioned, they'll slide across the locks and lift the car up again to its second height setting. This is just a setting that the air jacks will give us to enable the mechanics to get that extra height off the ground, but it wouldn't ordinarily be used in a race setting. Now the car's up high enough, they'll put the safety stands in on top of the elephant's feet. This just ensures that the car doesn't drop if the air pressure is removed from that pneumatic system. Once they've done this, they'll proceed to take the wheels off, position the pads that they leveled up earlier on, and then fit hub stands. Hub stands are really important. It gives the mechanics access to all the adjustment points whilst there is weight and load on the wheels. Now the car's laying on the flat patch on the hub stands, the mechanics are going to fit the bars to the front. This frame system that we can see there at the front of the car that the mechanics fit in allows us to put the parallel bar on the front, which is where the strings are going to run from. This red measuring device that the mechanics are using now on the car is just checking the ride height. There's a few points on the car, mainly in the corners, where we're really interested in making sure that the ride height is really accurately positioned. The mechanic's now using a digital inclinometer to check the camber of that wheel. That's the angle relative to the ground that that wheel is. Now the strings and the bars are fitted to the car, the mechanics will proceed to go around and ensure that that box formed by the bars at the front and the strings at the side is not only square, but it's parallel to the axles of the car too. That gives us a really clear datum from which to measure the toe angles of the wheels. The mechanics now are happy that the string box around the car is square and is in the right position, so they can measure from the black toe sticks that you see on the hub stands. The difference between those 2 measurements tells them how much toe the car's got, whether it's got toe in or toe out on that particular corner. Then they'll go on and they'll adjust those settings. They'll adjust the toe to make sure that that is within spec for the setup of the car. Once they've checked and set the cambers and the toes on the ride height on the car, the final stage here is just to set the corner weights. So what the mechanics are doing here is measuring the amount of load on each of the corners. The silver pads that you can see now underneath the hub stands are weighing scales. So the mechanics have zeroed those and they're now looking at the readings on the device that measures the load cells. This is really important to get a really neutral handle into the car. If you think of I suppose a table would be a good analogy. A table with 4 legs. If one of those legs is slightly shorter than the others, it's going to be rocking on the opposite corners. That's not a desirable handling characteristic in a race car, and so we make sure that the weight across the front left and the rear right is as close as possible to the weight across the front right and the rear left, hence the name corner weights. Now the mechanics are happy that the setup of the car is where the engineer requested it to be. Now get the car back on its wheels and back in its bay.
ready to load up in the truck and go racing.
The process that we use to string up a race car to check the alignment is really quite simple, but it's really important that it's done correctly and in the right order. It isn't just a process that's done before the start of a race. It's a process we do here at the workshop before we go racing to set the car to a specific set of settings. But then throughout the course of our testing process and even through qualifying, we're again adjusting these settings. And so this process that we go through happens over and over again across the course of a race weekend. That phase is the setup phase. And by the time we start the race, we know that we've got the ultimate setup for that car and that we've tuned it specifically for that driver in those conditions. Another really important part of that is after the race, we do the set down process, which is again to apply these measurement tools to the vehicle and to check where that setup has moved to during the course of a race. That's an important piece of data that then allows us to change the setup for the beginning of the next race, knowing how that setup is going to evolve throughout the race duration. For us, the process to get into a really fast setup really lies with the driver. We go testing with the driver in the car, and during that test, we're generating a lot of data from the car, and we can see how the car is handling, we can see how the car's behaving on the track at that point. But really the key thing for us is the driver feedback. So at the end of that session, the driver will get out and they'll have a conversation with their race engineer about how the balance of the car feels. Is it understeering? Is it oversteering? Is it worse on entry, worse on exit? Is it through the high speed stuff or the low speed stuff? This guides the setup decisions that the mechanics then use to apply to the setup of the car. When we're out testing, it's a really labour-intensive process for the mechanics to make sure that every time the car goes out and comes back from the circuit, it's then put on this flat patch again and set up. This process might happen 10 times during the course of a day. And so the repeatability and the precision of these measuring instruments is absolutely key, but also the speed at which they can be used is really critical.
So hopefully that gives you some insight into how we go about setting up these race cars using really low-tech methods to a high level of precision. I hope you enjoyed it, and don't forget to like and subscribe for more engineering insights.